Hello Internet, welcome back to DataSphere. We are going to be working on getting our data transferred into our project here. And to do that, we're going to be using named pipes. Took a bit to decide on that, but that's sort of the solution I think is best. Some of the alternatives were things like, well, throwing in a full web server and actually having it like accept web requests to post to it. That seemed like overkill and a lot of work. We would have had to probably throw like Owen and Katana on top of this, and I don't even know if that's possible. But that was an option that I considered. I threw it out because it was too much work and because that just seemed silly. So we're going to use named pipes, and so what those are there. Think of it like a file. So you've got a file on your computer, but it's not really a file. It's sort of a buffer. And so the way that works is there is that pipe somewhere on your computer, and one program is going to write to it, and the other program is going to read to it, or read from it. So it's sort of like how when you type letters on your keyboard, that's actually writing to a buffer, which is then being read by your computer and interpreted. We're going to do that, but we're going to send pieces of data from our source to our Unity project, and then we're going to interpret that as data and get this. So I have updated it a little bit. We have lights now. So the way you do that is you need Unity 5.5 because they added lights. Then all you have to do is take this light here. You should be able to see it. And then you just assign it the light you want to use. Give it the maximum number of lights. I did 1,000 because I was just kind of playing around with it. And 1,000 is the total number of particles. So every single particle has a light that it's emitting. This is going to be really slow, but I thought it looked cool, so I kept it. The other thing I changed is I added some alpha fade in and fade out, which is why all of this looks very smooth. So the light is based off of the particle color and its transparency. So if it's transparent, there's no light coming off of it, and that's how we're getting this fading effect. The other thing, was there another thing? Yes. So turns out that if you have execute in edit mode and you use that emit particles thing that we were using, so the particle system emit function, that crashes Unity if you run it in edit mode. And I hadn't realized that. So what was happening prior to me starting this is every single time I started Unity, as soon as I selected our particle system, it would start emitting particles and then it would immediately crash. That seemed like a bad option. So we're not doing that. So I had to comment that out. It's still, the code's still there. It's just commented out. But you can see our lights are working. Actually, I'm pretty happy with how it turned out. I think it'll look cool once we actually get other objects that you can kind of interact with it with. So they'll stay for now. The way you get multiple, so I'll demonstrate quickly what I mean by getting all these lights to work, or what I had to do. There's two things I enabled. First, I turned on HDR, which is going to be high dynamic range rendering. And what that is going to do is normally when you think of colors, you think of like black and white as like the two brightest things. The issue is there's things brighter than white. That's kind of weird to think about, but there's things brighter than what you are seeing. And so you'll kind of see this happen, like if you've played Skyrim, for example, you'll notice if you stare up at the sky that's really bright, things get really bright, or as you look up at it, things slowly get darker and it becomes easier to see the difference between the lights. And the reason that's happening is because of the high dynamic range. So the image itself is actually rendered in more definition than they can actually show you. And then post effects go through and actually pick out what they want to show. We're not really getting much benefit from that right now, but what we will get is if we ever turn on like bloom, for example, multiple different white lights may appear different colors or whatever, and we don't lose that information. So it's possible to have something so bright that it's just white, but it could actually be a red light, and so it'll have a glow of red. Things like that are possible. The other option that we changed was we turned on deferred rendering. So what deferred rendering is going to do is it's going to make it, what's the best way to describe this? So deferred rendering uses what's called a G buffer. So the idea is it's sort of telling the graphics card, hold on, wait a second, let's just write this information, and then I'll come back and finish it later. And so what you get is you don't get this image when you render it the first time. You actually have two rendering passes. And what happens is the first one is going to do all of your geometry. It's going to render everything. It's going to make sure nothing is there or whatever. And the reason you do that is because the fragment shader, the thing that is actually drawing it, is usually the expensive part. So when we have all of these lights, if we're doing per pixel lighting on all of this, that means that since we have 1,000 lights, every single pixel is going to need to calculate 1,000 lights. And that's not really performant in any way. It would absolutely kill your computer. And so that doesn't happen in what's called forward rendering. So what you end up getting in deferred rendering is it will draw this plane and this sphere. And it will say, this is a plane and this is a sphere. And here are their normals and all of this other information. It writes all of that to the G buffer. And then it comes back through and actually renders everything. And that means you only get one light calculation. And it's only as expensive as the number of lights that fall on that pixel, which makes that a lot cheaper, and it makes everything else a lot cheaper. So if you have really complex shaders, they can be a lot easier to do in deferred rendering because it just works better. The only issue with that is deferred rendering does not work with transparent textures because you write everything to your buffer, and there's no way to say there's two things here, do this and then do this. That's not possible. So when you have transparent stuff like our particles, there's actually a second pass that happens after all of this has been drawn that goes through and actually renders all of our transparent objects in forward rendering, which is just going to be the default. So it's more complicated, but there's a reason it's used so much, and that's because it gets you these really cool lighting effects. If we don't have deferred rendering on, if I switch back to forward rendering, we lose all of our lights. You'll see they're still there. We're still getting some of them, but I believe Unity limits it to 7 lights total. So we get this instead, which doesn't look as nice. So I figured let's bump it up to deferred and see what we get. And we'll see if we keep it here, probably. But for now, at least, it looks fine. And then the sphere there was just to check the lighting and make sure it was all working. Seems to be, but I kind of like the look, so we'll keep it. Anywho, that was enough rambling for now. Let's get to the actual thing. So what I did is there was a demo or a template of a client server architecture for this piped or named pipes. So I copied that off of MSDN. The source is up here. I'll post that in the description. And if you check out the source on GitHub, this link will be there still. So you can grab that whenever you feel like it. What we're going to do is we're going to be taking most of this. What this is doing is it's actually doing some multi-threaded thing to actually write into the pipe and then have something else read off of it. I think what we're going to do is we're going to implement our server, and then we'll do our client, and then both of those will be in the same project. And then what we can do is we can actually pull those out and have our client be a totally separate thing, just be its own C# application. And then everything should just work. At least that's the plan. I don't know what'll happen yet, but that's where we're going. Whoa, breaking everything. All right. So we've got our name server, and it's got all of this code. We don't need all of this code. So the easiest way to do this is probably, let's just grab, not that. Let's grab our, what was it? We want the named pipe server stream, which is going to be named pipe server stream. Okay, now this does not exist at all. So what we can do is I'm actually going to copy these usings up here, and then we're going to Oops. There we go. And then what we're going to do is actually try to figure out how to get this pipes library, I guess, included into Unity. And so I ran into this problem. I was kind of testing it out a little bit before just to see if this would work. And I still don't know because I got this far and then I stopped. So what we're going to do is we are going to take that and we're going to actually change some of our API compatibility. I'm going to bump it up to .NET 2. I honestly do not know if that's going to work because I believe this came in with .NET 3.5. And if that's true, then we're in for some fun. And I may have to do some other fun stuff to get around it. But we're going to try it. And so there's two things in Unity that you get. You get the .NET 2 subset, which is it's .NET, but they took some parts out that you probably don't need. And the reason they did that is because then you don't have to load the libraries and it saves you all of that extra space that you would normally have. The issue with that is sometimes you need it. And I don't think that's going to help us. Uh-oh. Remove unnecessary things, but it's necessary. Oh no. Okay. So, the solution to this is Google. I'll be right back. All right. So we dropped pipes. Those are out. So did some reading, and those aren't supported until Unity 4. Well, 3.5 actually, but we can't use them. I was going to write a plugin to do that, but that also is apparently iffy. So we would have had to have written a Unity plugin, converted that plugin into native code, pulled that into Unity, and then gotten it back out through COM and then used it in Unity, which is a whole big mess I don't want to deal with. So we're not going to do that. So the advantage named pipes were going to give us is, one, they were going to be a really easy way because it's more or less just pointed at a file and it will work. We aren't going to be using those anymore, so we're going to lose that. One of the things we are doing now is there were a few options I was kind of pondering over. I spent like 30 minutes looking at that. Anyway, what we were looking at is there are 3 options I was considering. One, create a folder and just have different applications drop messages as just strings into a text file, and then find the new files and read those, and it is sort of poor man's database. The problem is that's gross, and you should never do that, so we're not going to do that. We could have also just used the database. Didn't want to do that either, because then you'd have to set up a database and you'd have to do everything else to get that working. And I don't really want that to be something you need to do. I don't want you to have to do much other than download this and start whatever data socket you want. The other 2 options were you would select a program and then we would start up. So what you would do is you'd have this sphere. There would be nothing there. You would select a program from Unity. It would start the process for whatever plugin you had selected, and then it would connect to the output stream using the output pipe from standard out of the program, and then that program would just write out to that pipe, and then we'd read it in. That works, but it's still gross, and it means we have to have it running locally, and I don't want that. So we're doing sockets. Wasn't really where I saw this going, but it's where we're ending up. So sockets are really low-level networking things. Cool thing with this, you're going to be able to have external services. This is going to be able to call Google if you want it, and it will just do its thing. But we don't really want it to do that yet. We just want it to do its normal stuff. The problem with using sockets is you're still going to need to connect to something And I don't know if we can just open the port up and just have things connect to us. We may need to actually go out and find things. We'll play with that. I don't know how far we're going to get because I kind of just spent all of my time searching for an actual solution to this problem that didn't work. So, sockets. Right. This will be fun. So what I have down here, keep looking to my side because I have the actual MSDN page pulled up over this way. But I pulled all the code in here. So I swapped out everything we had, and now we're here. And this is gross. So what we're going to do is I'm actually just going to copy these two functions into our new server thing and hope it doesn't get too messy. So what I'm trying to do here is I'm trying to get it running, and then we'll go back and we'll get everything working. So I'm going to just include, whoa, that was my bad. I'm going to include everything, and then we'll run through and do stuff. So we've got our connect socket, which is going to return our socket. And then there's a socket send receive, which takes a server and a port. This is never called because this creates a socket and then sends and then receives and returns the page that we got. So here's what we're going to do as a demonstration. We've got our socket. Do we actually need that? No, we don't. It's gone. So let's create a public string. We'll just call it the server, I guess. That's close enough. And we'll do a public. Ooh. Do we actually need anything? Yeah, let's give it a port, int of the port. And we'll just expose both of those, and then we will have our response. Public string response. Then when we start, let's just do a socket something. Send receive. There we go. And we're sending it to our server with our port, and we're setting our response. And so what this is going to do is it is going to come down here. It's going to create a GET request for our server. And then it's going to encode our request message into ASCII. So just byte encode it. Then it's going to create a new received array. Don't know why it's only 256 bytes. That might be interesting. Maybe. Anyway, we have our socket. This is just going to connect, which is going to come up here. It's going to do a DNS lookup, which is going to actually find the DNS server. And then based on the server, it's going to say, where is this? And the DNS server is going to say, here it is. And that's going to eventually give us an IP that we can go to. Then for that, we're actually going to iterate over the potential addresses, the potential IPs. And then we're going to wait until we find one of them. So we're just going to try to connect to all of the available ones until we connect to one. And then once that happens, then we just return that socket. Then we come back here. If we didn't find one, then our connection failed. Otherwise, we send our message, which is just going to be a classic GET. And then we have our bytes, and we return the page, which is default HTML page on wherever. And then while there's bytes, we just keep adding to it. So theoretically, if this works, we should just be able to download a page off the internet. Let's see if that works. So I'm actually going to connect this to our particle system. And the reason we're doing that is because we're going to use messaging to do this. So I'm going to fully encode this. And we'll connect on port 80, I believe should be good. And now let's start this and see what happens. Ooh, no such host is known. Interesting. HTTPS. We may be connecting on the wrong port. We'll kind of have to do this by ear, I believe, because I don't know what I'm doing. All right. Oops, my bad. Reset it again. Okay. No such host is known. This is weird. Get host by name, no such host is known. So the issue we may be running into is the current version we're using is not technically supported anymore. I hope that's not the issue, because I can't fix that. If it is the issue, we'll have to work around it, which means we'll get back into plugins, and this was supposed to be so easy, and if Unity had done what they said they were going to do, it would have been. They were supposed to release .NET 4.5 support and Unity 5.5. They didn't. They just released the .NET 4.5 compiler, which is a good first step, but it's less than we were expecting. And it doesn't look like it's going to come in Unity 5.6 either, which means we're stuck with this until at least Unity 6, which kind of is unfortunate because they've been talking about it since 2014, I think. So we're going to try to make this work. And I don't know how far we're going to get, because this is this. Let's stick a debugger in here. So we've got connection failed. I'm gonna drop a breakpoint there and attach to Unity. This is going to start up Visual Studio's debugger connected to Unity, which means we can now start this again. And we should be able to walk through what happens. That happens. Okay. So our DNS host entry is throwing a exception. That's fantastic. Okay, so I'm going to delete all of this. Turns out I was thinking of this the wrong way. You don't connect to web servers like this. I got a little bit ahead of myself. There's more that you need to do to get that to work. What we can do, though, is we can set up a TCP Listener, which is this guy. So, TCP Listener. And then what we'll do is our client will be a TCP Client. And so TCP and UDP are the two networking protocols. TCP is guaranteed to be ordered and delivered. UDP is sort of fire and forget, and it may arrive out of order, but UDP is going to be faster. The advantage of TCP is while it's slower, you're guaranteed your message will arrive, and if you send two messages, the first one will arrive before the second one. So if you get the second one first, the client just or the listener in this case will just hold on to it until our latest message arrives. So we have this, which I'm pulling again from MSDN. I've been doing that a lot and it has not worked well, but this one ought to be different. And if it isn't, then oops. So what we're going to do is we are going to create a very simple TCP listener. And what this is going to do is listen for messages. So all it's going to do is it's going to sit on, in this case, our port. Can actually just pass that in. Can't do this, so appreciate it if it would not finish my word twice in a row. But anyway, I'm going to use the current port. I'm actually going to pass it in here. And then we can drop that. So we've got our port. Our server will be localhost, which is going to be our current server. And all we're doing is we're spinning up a TCP listener. What that does is it's just going to sit there. Clients are going to attempt to connect on the port and at the IP of our current node. So somebody can say, I want to listen on localhost, which is this. Then they say, I want to listen on port 80, for example. We'll do that as well. Then we'll come here and we'll actually do all of our fun stuff. The only issue we're going to have here is we want all of this to happen asynchronously. That's the hard part. But I think we can fix that. Don't know how yet. Let's do probably a thread. Because I think we're too early to be able to use tasks. So we're going to have to go back to threads, which is going to be a listener thread. So we're going to have a thread that's going to be listening for those messages. So this way it won't block anything while it's waiting for those, and everything else in our game will just function fine. If we didn't do this, it would stop and wait. This is actually an infinite loop here. So we would never actually do anything. Another one of the cool things is that things connect and then we read their message and then we disconnect them. So this prevents any single host from actually taking over our client, which is a good thing because it means we can just have simultaneous inputs from a few different people and it shouldn't cause too much of a problem. I don't think. We'll see. We'll see what happens. I'm kind of wandering into the realm of this being way more complicated than I thought, and I'm not entirely sure what I'm doing anymore, but this seems like the best solution to our problem, so that's what we're going to do. In our start, let's spin up our thread. Equals a thread pool. No, we don't want a thread pool. We want just a thread. Dot. I don't remember how to do threads in C# because I'm used to tasks. So we're going to do a new thread with a new thread start. And if I remember, our thread start is what we're actually going to be doing. So I think I can just do something like this on our port. Yes. Okay. So what we have is we have a new thread. It's going to do our listen for messages. And it's just going to sit in this while true loop and just wait for everything to happen. And then as soon as it's done, it's going to clean up and stop the server. So with that, we can start this, which I believe we just call start. Yeah. So this is going to start our thread and it's just going to go. Just to make sure everything is working, I'm going to do a debug log of, we can actually just copy all of this. So I'm copying it to use the Unity's logging system instead of the default console log, because we won't see the console log in Unity's editor. So I'm just going to replace all of these really quick. And it's going to hate those. And this will be a debug log error. And then let's do a string format on this so that we maintain all of that fun little data that we're trying to keep. So we've got this sent and we're plugging in our data here. So we want to keep that. I could just delete it for now, but we're going to want it eventually, so I'll do it now. And we should do that. Did I miss any? I think I got them all. Nope. So we'll do a debug.log, and this is going to do a console read. We definitely do not want that. I'm actually going to delete both of those. So all this is going to do is it's going to come here, start up our server, and then it's just going to enter a loop that's just going to receive, it's going to accept a connection, it's going to receive that data, and then it's going to close that connection. Somewhere in here, we're going to actually maybe even send a response, which we can actually probably do by doing something. I don't know if we need to send a response. That may not be necessary, but we have it. Then we close the current connection and just loop. So we'll just keep accepting connections, getting data, and so forth. Then if we ever leave that loop for any reason, we'll close our server so it doesn't take over our port for any reason. And hopefully that's all good. And we have our server going. Now, what we want is we want to actually run something that connects to this, which means we need to do this little bit of fun, which we don't have because none of this is going to work. And so you can actually connect with this using sockets or a TCP client. We're going to use a TCP client because I don't want to deal with sockets. Because sockets are, they're so low level that one, we don't need to get that low level, and two, because they're so low level, you saw this is actually not that complicated. It's fairly easy to read, and there's a lot of this is mostly debug stuff and actually just orchestration stuff. You lose that the lower you get, and you have to do more and more to actually make it work together. And so I want to avoid that as much as possible. I want to make this simple to understand and also work well, which means writing less code because then it breaks less. So what we're going to do is we're going to use a TCP client here, which I'm going to have to copy from MSDN right now. All right, so I've got the source here. So we should be able to just drop this here and we should be good. They're using just a simple connect, which connects to a server and sends a message. And that actually works for what we need. I'm going to remove the static because I don't like global stuff like that. And we're just going to pass in a server and a port, which is going to require an int port. There we go. And then I'm going to expose the server, which is going to be a string. So like this, we can expose all of those variables. And then let's actually not send a message. I've got a plan for what we can do for that. So we've got the server and the port here. And then what we can do is we can actually make a public void send message. And this is going to take a string of the message. Then we're going to connect to our server using our server, our port, and our message. And that will actually send it off to our server. What this gives us is it lets us hook this into Unity's UI. So theoretically, what we can do is take this named server stream. I'm going to open it up on port 8080, which I think is just default web stuff, but we have this. Let's also throw on our named client stream. And actually, I don't want that there. What I want is I want it on a new UI object. Where is it? Canvas. There we go. So we have our canvas. I'm going to bring this into a camera space thing. I'm going to attach a camera. We'll attach our main camera like so. And then I'm going to bring it in so it's just a meter away. And we can shrink this down because I don't know why that's that big. And now the cool thing is we can attach our client like so, stick it on port 8080, and have this be 127.0.0.1 or home. And then the fun part is we get to add two things. We're going to add a panel, which I'm going to center with a width of, let's say 300, and a height of 100. Sure, why not? And then let's stick in a text box, which is here. And then let's stick a button on there as well. So we do that, drop our button. And now if we put our button on the right side, oops. Oh, there we go. And then we can put our input field on the left side, which is going to be left and stretched. Yeah. That's not right. What am I doing? This is a good question. Yeah, that's what I wanted. Cool. So we have our text box there, and then we have our button there. What we can do is we can input data into our text box, click the button, and theoretically send it to our client, which will send it down our stream, theoretically hitting our listener, which will print it out. That's the plan. I have no idea if this is going to work. For now, I'm actually should probably skip things, but no, we're going to send it every single time you edit this text box, because screw it, that's easier. So we'll connect to our named client. We will send out. Ooh, did I really call it send message? I think I did. That was a mistake. Send message to server. There. Problem is we can't call it send message because that already exists. That's a default Unity function for their message passing thing. So we're going to send a message to the server, and we are going to send something. What do we want to do? No. We'll just hook into the button. That makes more sense. Stick the button there, connect everything. And so what I'm doing here, I'm kind of going through this fast because I've been recording for like an hour and a half now because I haven't really gotten anywhere. But what I'm doing is if you connect your object on click, it will expose all of the public value or variables, public functions and variables on it. And then what you can do is you can take that, I'm looking at the name client, send message to server, and then that accepts a string. So we just input a string. Hello, world of sockets. Cool. So what this does is it sends our hello world of sockets across our named client stream to this server with this port. So every time you click this button, it will send it up to wherever. Waiting for a connection. If I hit button, we get sent and we get a received, which is fantastic. Huzzah! So it works. So what we're getting here is we're actually getting a received and a sent. Those are actually both coming from our server. If you look here, we actually respond with the completely capitalized version of this. So now that we have this, what we can do is we can actually come up with some sort of canonical model, some sort of data model that will represent the data that we want to represent in our actual Unity project. Then what we need to do is throw in some way to parse that data here, because all we're doing is we're just taking the text and then throwing it back. We want to actually intercept that, plug in like a JSON parser, for example, which wouldn't be that hard. Take that and then send it back, probably using message passing, send it up to something else and have it do something. So theoretically, if we're doing this right, we should be able to now accept things from any client. It doesn't have to be like right now we have it in Unity and it's kind of lame. But what we can do is that we can actually take these client streams. Oops. So we can take these client streams and actually pull this out into a separate package and then make this into its own separate client. We'll probably connect it to Twitter first. I think I talked about this last time, but we're going to connect it to Twitter, and then we're going to actually use the geodata from that, like a specific hashtag, for example, and we're actually going to send that over this to that. And so this code, since it's just .NET code, will work everywhere. The only thing we have to do is get rid of this mono behavior and some of that stuff, and we're good to go. So that we can pull out, do a separate thing. We can take the server, make it actually parse the message, and then we should be good. And everything should work. And better yet, this will accept data from anywhere, which it's not the most secure thing, mostly because it doesn't, there's no authentication. Anybody can send any data they want. But the cool thing with this is that since anybody can send anything, we can have data running up on a server somewhere, and it can actually send data down to us. And we can just take that and represent it in our graph. So as long as you don't care about the security of that data, this is a good solution for that. And if we want to add security, I think we can. I don't know how to do that, but we may look into it into the future. So this is where we're at right now, and it took longer than I expected, but we got there, and it's actually, I think it's probably a better solution than named pipes, just because named pipes are kind of gross. And this way, more or less what we have is we have a really bare bones, just client server architecture. And so you just work it like any other client server. You connect, you send your message, and you disconnect. So I think that's a pretty good solution, and I hope if you guys can think of something better, let me know, and we'll look into that, because I like the solution, but I don't like the solution. So I like it because it's simple and it works, and it also has some good assurances that messages will be delivered. They'll be delivered in the order you want them, and we can have multiple different clients connect and send their message without having all these weird issues of somebody is connected, so therefore nobody else can connect. So if there's anything you guys want to see, let me know in the comments, and I'd love to hear your thoughts. If there's something you guys thought needs more work or you'd like explained more, let me know about that as well, and I'll look into it. So until next time, see you, Internet.